All right, good evening, everybody, and welcome to PTC Outreach's Intro to Cybersecurity workshop. We're excited to bring this super interesting field to you through this short workshop. Your hosts today will be our PTC Outreach directors from across Canada. My name is Timerl, and say hello to Sarah, Isabel, and Ifra.
Before we start, just a little bit about Project Tech Conferences. PTC is a student-run nonprofit organization. Our mission here at Project Tech Conferences is to provide accessible opportunities for students like you to learn about the field of technology. We hope that through events such as workshops like these, each of you are able to gain a new understanding of different topics in the field.
The goal of today's workshop is to provide students with a glance at key parts of cybersecurity world, namely cryptography, forensics, web exploits, and reverse engineering. Don't worry if that doesn't mean anything to you yet. We'll explain each and every one of those in depth throughout the workshop. If you have any questions at all throughout the workshop, we've got some awesome members of our team in the chat, so shoot a message in the chat or use the raise the hand function. If you'd like to keep your question private, you can just private message any of the PTC members. We have a PTC and a dash for our name, so you can contact us and ask your question, and we'll try and get those answered for you.
And here is the agenda for today's workshop. So before we get into the workshop, the first point of business is to make sure you're all set up for it. That means you've either got access to Linux terminal, either through your Mac computer, the VirtualBox VM we recommended in our email, or your own way. Personally, I'm running the VirtualBox VM on my Windows computer. It's like running a whole other computer on top of your own. This can be advantageous in cybersecurity as it separates your own computer with its CPU, storage, etc., from the one you're using to access all kinds of risky material like malware and such. It's like a digital hazmat suit. Not to mention, Linux terminals have all kinds of commands that are useful in cybersecurity challenges that you can't do in the Windows PowerShell.
It's also important to make sure that you have accounts with the following sites. So the first one is Pico CTF or Pico Gym. This is a fantastic site to hone on your CTF skills. They even have a web shell in case your VM doesn't start up, and it's basically a Unix shell. You can practice with all different kinds of activities and even check out the activities we will do today.
You'll also need to have Postman. So Postman is a platform that you use to create and test APIs, which is short for an application programming interface. These are created by developers as an intermediary to allow applications to quote unquote talk to each other. Most actions you do on the web, like sending a message, accessing a web page, logging into your account, all of these make use of APIs. Postman is an easy platform for you to try sending those requests, which consist of the URL, the request body, which has the information and data you want to send over, things like headers, etc. And it in turn helps you with web-based cybersecurity tasks that you can test by sending requests out and essentially debug to see the response without having to physically go to the site or send the request via your terminal or using tools like curl or other more complex ways of approaching this. So Postman really does make things a lot easier.
Finally, we'll need an IDE. That's an integrated development environment, or a text editor with basic functionalities to really help you with the more programming-based challenges like reverse engineering. You might have to write scripts or even debug code to see where vulnerabilities might be. An IDE like IntelliJ will help you debug, but you only need a text editor for today.
This was all in the email we sent out yesterday, but that was some information on why we use each of these tools. Make sure these are set up because you need them for the activities. If you don't have any of these set up and want to do the corresponding activity, take a bit to set them up now.
And like said in the chat, we'll give about 5 to 10 minutes to troubleshoot any issues.
Yeah, again, just quickly running through the list. You've got the VirtualBox VM, Pico CTF account, Postman account, and a text editor of some kind. So that could be VS Code, an IDE like IntelliJ, things like that. Nice, that's truly said in the chat. Feel free to ask your questions either just in the general chat or directly message any of our PTC members for help.
Okay, hopefully everyone is done setting up or they're setting up those last couple of steps. Um, let's, while you guys are still getting those last things set up, we'll do a brief introduction of what cybersecurity is. So if you were to ask people what cybersecurity was, a common response would be keeping digital things safe, which is kind of the obvious answer, but it's also the right answer. But a more detailed explanation or definition of cybersecurity is the protection of computer systems and networks from cyber attacks, such as information disclosure, theft, or damage to hardware, software, or electronic data. Cybersecurity acts as a shield to prevent unauthorized exploitation of data and technologies. This is especially relevant today where networking and wireless access makes it easier for malicious users to connect.
We also want to introduce you to CTFs, like the one in the name of PICO CTF. That stands for Capture the Flag, and it's a computer security competition where individuals or teams compete against each other in challenges ranging from a scavenger hunt on Wikipedia to hacking a server to steal data. Due to its team-building nature and competitive aspect, CTFs are often the beginning of one's cybersecurity career.
Now here's your short primer on all that is cybersecurity. It protects all kinds of data from theft and damage. Data like intellectual property, personal information like passwords and browsing histories, protected health information, and government and industry information systems. Because our society is more technologically reliant than ever and only expanding our digital networks and connections, we'll keep becoming more prone to cyber attacks. Without cybersecurity, all of that data would be an easy target for cyber criminals.
That data could lead to identity theft, like someone stealing your Instagram account and making posts under your name, or getting your bank information if it's on Google Drive and taking your money. It's no wonder information theft is the most expensive and fast-growing segment of cybercrime.
Now, there are various motives for why cyber criminals do what they do, some of which are with an intention to harm a person by stealing their identity or to compromise data integrity to propagate distrust in an organization or a government. Also to disclose information or reveal trade secrets and intellectual property. Also, there's the motive to get rich off of insider trading, identity theft, and such, as well as industrial espionage.
There are also a lot of reasons why cybercrime has grown. And this could be because the distributed nature of the internet, the ability of cyber criminals to attack targets outside their jurisdiction, making policing extremely difficult, the increasing profitability and simplicity of commerce on the dark web, the increasing use of mobile devices and the Internet of Things, devices like smart fridges and Alexa, and plenty of other reasons.
And of course, cybersecurity and cybercrime can have disastrous consequences. It could greatly financially hurt a person or institution. It can discredit them and breed distrust in the people that they're serving. It can incur massive regulatory costs, and it can possibly revoke someone's access to their digital identity. And that's your primer. Hopefully you learned why this work is so important and also have your system set up to learn how to get started. Now, before we actually do get started, here's a few important and fun notes about CTFs. CTFs are challenges where you try and find a flag, a specific bit of text. Flags usually have keywords to help you find them easier. So in our case, it'll be PICO CTF. You'll see what we mean when we actually get into the challenges. And a third thing to remember as you pursue these kinds of challenges after this session is that challenge descriptions, titles, and such often have clues hidden in them. So be sure to read them carefully because they will actually be very helpful, as you'll see in some of these challenges.
So now moving on to cryptography. So what is cryptography? It is the method of protecting information and securing communication in order to allow only the sender and the intended recipient to view its content. You can encrypt a message, meaning you turn your intended message into something incomprehensible based upon some key. Encrypting this message with the key can look like a lot of different things. So how is it used in real life and in the industry? In 2013, Adobe announced that their systems were hacked and attackers accessed information relating to 3 million Adobe customers, including encrypted credit or debit card numbers. But there is a sliver of good news, which lies in a single word: encrypted. The fact that some of the data was encrypted means only a portion of the data that was taken has any value to the perpetrators because the rest cannot be read. This is an example of how cryptography can be used to protect the information of a company's clients. The tool of encryption can and should be applied at numerous layers of companies to protect, isolate, and control data. Essentially, they act as a shield against data thieves. So now moving on to crypto activity. So Caesar ciphers is a simple cipher that uses the alphabet to encrypt messages, typically by shifting the alphabet a certain number of times. For example, if the shift is 1, B in the message will be A in our alphabet, and so on. And the shift is the key. So now I'll give you a few minutes for you guys to try it yourself and decode the message on the screen. Okay, so this exercise is quite simple, but might take some time since you do not have to brute force it. A good thing for a lot of crypto exercises is to try to decryptors that you can find online. They can brute force it for you and give you possible answers. If you have the key for a lot of these cipher type challenges, you can use those to decode the message. So here I'm going to paste the message that we use as an example and then decrypt the Caesar code. And then it gives you the answer, the best answer at the top, and it shows that it shifted 10 times in our alphabet. So that's as simple as it is, and that's all you need to do. Sorry, I'll just try that again. So I have the code pasted here, and then I press decrypt Caesar code, and then it shows you the best results at the top, and right here it shows +10 because it shifted 10 times in the alphabet. So the answer is "and you, Brutus," which is a quote from Shakespeare play. So some of the takeaways from this activity, you can always try and find tools online to help you decrypt if you have an idea of the type of cipher, encryption, or key it's using. And you can use the link in the chat for common ciphers.
We're now going to be moving on to some forensic questions, and a forensic question in CTFs is a question or a challenge that asks the participants to find a piece of hidden information in a file that has been hidden or camouflaged somewhere. And these challenges can include file format analysis, steganography, memory dump. One that we're doing today is from the PICO CTF website, and we'll share a link with you all in the chat in just a second. And I am going to share my screen right now and walk us through that. So this challenge will only work on a Unix-based system. So if that's a Mac OS or a Linux type system. So if you're on Windows right now, or you should shift over to the virtual machine that we showed in our introductory document that we sent to you by email yesterday. So as you can see, I have the website up on my virtual machine over here, and it should bring you to this on your account. And what we're going to do is we're going to copy the link from the website right over here. And you can see that the name of the challenge is disk sleuth. So we're going to be sleuthing in some data. So I'm going to open up my terminal, and the first thing that we want to do is get the file off of the internet and onto our computers. So to do that, we're going to learn a few new commands for our terminal, and the first one is going to be wget, which will just find it on the internet and bring it down onto our computer, so we'll have a local copy. So we're going to paste the link that we copied from PICO CTF, and it should look a little something like this, or if you click on this, you can also copy it like that and save the file yourself. But I'm going to do it this way so we can get familiar with the terminal, and then when I press enter, it'll start downloading it, and we just have to wait a second for it to download it completely. And now that it's downloaded, we want to see what type of file we're working with so we can better approach the challenge. So to find out what type of file it is, we're going to type file. Oh wait, first we're going to see if it actually downloaded onto our computer, and to do that we're going to type in ls, which will just list all the directories within our current directory and any files that are there. And we can see here that it says dds1 alpine.flag.image.gz. So we can see that downloaded onto our computer just fine, and we can now see what type of file it is. Although you might be able to guess from the end of the file name. So we have to type in file and then the name of the file that we're trying to see what type of file it is. So dds1-alpine.flag.image. Oops, I typed in flag twice. .gz. And then this should tell us what type of file we're working with. And we can see here that it is a gzip compressed data. So that means that it's a zip file. You might be familiar with those. So if you're familiar with them, we know that we can't really do anything with it when it's zipped. So we're going to try and unzip it and decompress the data so we can actually work with it. So to do that, we are going to use a command called gzip, which is the same as the file you might have noticed, and which will just decompress the data. So we're going to do -D to decompress and unzip the file. And then we have to, once again, just type in the name of the file so it knows which file we're trying to unzip. alpine.flag.image.gz. And then we can do that. And now we can type in ls again just to see what the file looks like now. And we can see that unlike before where it had GZ and it was in red, it's now white and showing us that it is unzipped and it does not have that GZ extension at the end. So now that we have it unzipped, we want to do something with it. We want to find the flag. And to do that, we will need to extract the data from it. And to open the file and kind of look into the data that's inside, we're going to use a technique called plumbing, which will extract all the data in one stream, and then we can use other commands to process that data and find what we want. So you can imagine it like one command after the other, we're directing all this data like a plumber. So to open the file, we can use the cat command. So just cat, and then we're going to type in the name of the file again, and just remember that there's no GZ at the end because we unzipped it. So we're going to do dbs1-alpine.flag.image, and then this will open it, but now we want to process that data actually. So we're going to use something, the command called strings, and this will print out all of the readable data that is contained within the file. So if we do that, a lot of data will come out, and I can show you guys actually. So this is a lot of nonsense to us, although it's deemed as the readable data, but we're looking for something very specific. So as this works out everything, we don't want to look through this entire, like, must be pages of stuff that's printed out. So what we actually want to do is look for something very specific. And we know that with Pico capture the flags, they're all formatted in a similar way. So they're formatted as Pico CTF, and then there's two curly brackets, and then that'll have the flag within it. So if we want to find a very specific something, we can do the cat command again, dbs1-alpine, oops, that's an equal sign, alpine.flag.image, and then we can again do the strings, but we'll add one more command, so feed it through one more pipe, and we're going to use the grep command. And what this will do is look for something very specific within the readable data. So what we're looking for is a flag, so Pico CTF, and then we can press enter on this, and it should find exactly where the flag is for us. So you can see that it's working a little bit, trying to find it, and we see here it has Pico CTF, and that's highlighted in red because that's the thing that we were looking for. And then within our curly brackets here is the flag that we're looking for. So we can see it's forensicator something, I can't read it, but that is the flag for you. And that is a little introduction into some forensic questions in CTFs. So some key takeaways from this are some basic terminal commands like the wget to download a file, the file and ls to look at files and see where they are and what type of files they are, the cat command to open a file, the gzip command to unzip files, and -d to decompress. And we can send all these into the chat if you didn't quite catch them while I was walking through it. And we'll also send a manual pages that are helpful for describing some of the different commands you can use within the terminal. And I'll now pass it on to the next activity of web exploits.
Awesome. Thanks so much, Isabel. Forensics is definitely a useful skill in cybersecurity. I'll be covering my favorite one, though, one that some of you might be unknowingly familiar with if you've ever opened up the dev tools on a website. And if you don't know what those are, I'll get there. Of course, I'm talking about web exploits. Web exploits are a form of malicious code that takes advantage of a vulnerability in a system within the internet to breach a website's security. So getting a little more technical, there are different kinds of exploits. An injection attack is when the website accepts a malicious input from an attacker without proper validation, causing it to do things like reveal information that shouldn't be open. A misconfiguration attack happens when processes are manual and settings are mal-maintained, things like having a default administrative access code, so Like if their username was set to admin and password was 1234, the admin probably uses that to test whatever this website is. But if the hacker knows that, then they can just type that in and get full access. There's also cross-site scripting, which is when the server accepts untrusted JavaScript code through user input and executes it for other users, causing the server to malfunction for everybody. And then finally, authentication and authorization exploits are when the URL exposes a session ID or when passwords are encrypted. And this would basically give, exposing the session ID basically gives the hacker access to your current tab. So if timeouts are not correctly implemented to close your session when you actually close the tab, session hijacking by hackers is very possible. And all these exploits are used for plenty of reasons: to steal data, to spread a computer virus, to deface a website, and ultimately, of course, to make money. And you need to know all of these for 3 reasons. A cybersecurity professional needs to be able to protect against them and use them to actually test and strengthen their own security. And also because they're useful in CTFs, and CTFs are a ton of fun. So now we'll open up the CTF itself. The link is now in the chat. It should be called Get Ahead. If you remember what we said at the start of these activities, you'll know that the title is actually an important hint. So I'll start sharing my screen and we can get through this part. So if you open the, 1 second. There you go. Awesome. So if you open the link in the chat, it should take you to this Tycho CTF page, right? Get Ahead. Now from here, we want to read through this carefully. So the title is Get Ahead. The description is find the flag being held on this server to get ahead of the competition. Open that up. Quickly take a look at the site. 2 buttons: choose red, choose blue. Now if we go back to this Tycho CTF page, we'll see that there are also 2 hints. The first hint is that maybe you have more than 2 choices. And the second hint is check out tools like Burp Suite to modify your requests and look at the responses. All right, so if we go back to the site, immediately you can see what they mean by the first hint, that right now we can only have 2 options, right? Choose red, choose blue. And the site is suggesting that there may be a 3rd option. Now, it's always wise when you're doing web exploits is to inspect the page. So you can do that by right-clicking and pressing inspect, or Command Option C on Mac, or Control Shift C on Windows. And this opens up the dev tools, right? So quickly, we can just look at elements first. This elements tab will display the HTML code of this entire web page. And we can quickly scroll through the body, or even right-click on what we know might be interesting, which are these blocks here. These, like this: red, choose red, blue, choose blue. And we can see that this is a panel heading, panel body. If you expand everything all the way out, you'll see that the form action, which is what actually submits something whenever you click a button, the form action for the choose red button is using the get method, and the form action for the blue button is using the post method. And that gives us another connection back to the first hint of maybe you have more than 2 choices. So you don't need to actually know the nitty-gritty details of the get and post commands, but what you do need to know is that these are both requests that are being sent. And to give a quick overview, there are certain things happening behind the scenes when you press a button, like choose blue, either that or when you go to a certain URL. Request methods such as get, put, delete, head, post, all of the things like that are a few standardized methods that developers code to allow backend to respond to certain things that the user does in a certain way. For example, when you go to Google, you are sending a GET request to access the page. So if you look at, say, google.com, right? You're sending a GET request to their servers, and the backend does its magic and sends back this Google web page. A GET request is usually sent to retrieve some information, and navigating to a URL is commonly a GET request. Post requests, in most cases, are for when a user or application, called the client, provide some information to the backend server to potentially be processed or to retrieve other information. And you can read up on all of these. Yeah, you can read up on all of these things in the link we sent in the chat. But for our purposes right now, that's the general idea. So going back to this HTML, this entire HTML page, you can see that, again, you have the post and you have the get methods. And this is where our next two hints come into play. The second hint is check out tools like Burp Suite to modify your requests. So we know that we might need a different kind of request. And if we go to the network page in the dev tools, we can see under network, press index headers, that is under post right now. You click red, you have a get request. Again, that just reaffirms what we found out from the HTML code. And this is where the third and final clue helps us understand exactly what's happening, which is the title, get a head, and head is capitalized. So if you take a quick read through the Mozilla Dev Docs that we sent in the chat, the head is actually another kind of request, and the head method asks for a response identical to that of a get request, but without the response body. For our purposes, that doesn't really matter. We just know from here that we're going to need to send a head request to this page. So of course, the next step is to actually send a request, and that's what we needed Postman for. So if you go to postman.com and launch Postman, from here, this is where we are actually going to send the request, and that's what we were discussing way at the top, where Postman is very useful for testing APIs and things like exactly like what we're doing, sending these kinds of requests. So once Postman loads, on the top left, you'll see workspaces. And if you've already done this, then you should have a workspace ready. If you haven't set everything up yet, then you can make a new workspace there and whatnot. On the right side of the workspace, you can select create a request. Perfect. Here, we know that we want to send a head request, not a get request. So you just click that button and then scroll down to find the head request. And we need to send it to this URL. So just copy the URL that is at the top of the challenge page. Right, this choose red, choose blue page. Paste it into here. Send a request. And this is the output of the request, right? It says everything's all good. You can see that there's nothing in the body because, again, a head request returns no body. Nothing in the cookies. And if you check the headers, right there, you'll have a flag, right? Key, flag, value, PyCoCTF, reject the duality, and a ton of numbers. So right away, we know that that's our flag right here. So if we just copy that, head back to the PyCoCTF challenge page itself, and submit this flag, and you'll see I've already done this, so you've solved this challenge correctly again. If you've done this, if you're following along, it will say that you got your key, you got your flag. So congratulations, and that's the web exploit challenge. Now, I also want to take a quick aside to point out something cool that PyCoCTF does, which is its own web shell on the side here. And I don't mean to overwhelm anyone, but just really quickly, something to look into if you're going to continue to do these kinds of things. And if you don't want to spend too much time using things like Postman, you can use this web shell or your own Linux shell and do things like, let me sign in first. You can do things like the curl command, which will send, curl itself is for retrieving a URL. Then you can type in dash, so the second thing, dash capital I, head, and then dash smaller I. And that'll be for sending, that entire part is for sending your request. And again, here you can just paste in, not that, you can paste, sorry, or type in your URL, I suppose. So mercury.picoctf.net. Goes picoctf.net. And then you have colons 28916. Right, and here it returns exactly what Postman here returned, which is this confirmation that everything went all right, and it shows you what it returns, which is first and foremost the flag. Right, so that's just how you use the same Linux shell or the picoctf web shell to achieve the same thing that Postman does. So that's something to look into if you're interested in pursuing these kinds of challenges further. But that's that. That is all the important stuff for starting your journey to.
I don't know what happened to Timurl, but that was the end of the web exploits activity. So we'll now be moving on to the last activity of this workshop. I know we've been going through really fast, but don't worry if the other activities were a lot to understand. The next one is pretty simple and it kind of gives us all baby steps into what reverse engineering is. So first, let's go into what reverse engineering is in the first place. And in a nutshell, an idea or an example to try to get a simple understanding of what reverse engineering is to think back to if you have ever disassembled a pen to understand how it works. So taking apart the different pieces and trying to find out what each piece does in order to figure out why the pen works the way it does. Well, basically, it's the same concept behind reverse engineering. So reverse engineering is breaking something down in order to understand it, build a copy of it, or to improve it. So, for example, when a new machine comes into the market, competing manufacturers often will buy the machine and then disassemble it to learn how it was built and how it works. So reverse engineering is a really helpful method in order to understand how different technology or even code works. Now, although it can be very, very helpful, it can also be used unethically. By taking apart systems, it can expose security flaws and questionable privacy practices. And such privacy practices include the removal of copy protection, which is also known as cracking. So some of you may know what cracking is, but for those of you who don't, by definition, it is a method of making software function other than what it was originally intended to by the means of investigating the code and, if necessary, patching it. So those who perform cracking are called crackers, and they use reverse engineering to understand the protection scheme of a system and break it. So these practices can be quite harmful to the consumer society and violate the right to intellectual property and the right to authorship. Now that you have a brief understanding of reverse engineering, let's go into the activity. So if you guys download the file in the link that will be available in the chat now, download the file from this particular activity. And now I will start sharing my screen. Okay, so I've opened up the file that we've put in to the chat. Hopefully you guys have this opened up in your favorite text editor. I like Visual Studio Code, but use whatever IDE or text editor that you like. The important step to reverse engineering, or the most important first step, is to read through your code. It's really important to understand what's already pre-written and understand why your code is structured the way it is. So if we look through our code, we can see that the file has given us no explanation, question, or problem description. So this is actually quite common. in reverse engineering challenges because we should be able to use our skills to determine the flag from the code. It's also really important, like I said before, to read and understand what it's doing and then also play around with it. So if we look through the code right now together, we can see that there are two functions. So the first function called decode secret, if we read through this particular block of code, we can see that it's decoding or decrypting something that's inputted. So it takes in a string and then decrypts it. Why this function is in this file right now or why it's useful, we don't really know yet, but knowing that this function is there might be helpful later when we're trying to find the flag. The second function here is called choose greatest. And so this is a lot easier to understand for those who are not familiar with Python. And it looks like it takes two inputs from the user, two numbers, and then determines what the higher integer value is. So we don't really see where the flag could be in this code yet. So the second step would be to run our code and see if we can try to isolate for an area to look through. So let me go into my terminal and I'll first change my directory to where my file is. For most of you, if you've just downloaded your file, it'll probably be in your downloads. And now let's run our file. Oh. Okay, it's asking me to input two numbers and it returns the highest number. So it looks like this particular function is working. So this kind of signals that the flag that we're looking for is probably not in this particular block of code. So we can use process of elimination and try to look at other parts. So this particular line, number 4, is pretty interesting. It looks like we have a secret code, which is usually a sign that that is the flag or it will at least lead to a flag. And also the comment here provides some insight and tells us that it is encrypted. So if you guys remember, we saw that there was a decryption function written within the code. So if we have an encrypted code, and a decryption function, then all we need to do is call on that function with this secret code. So all we have to do is add an additional line of code where we call on the decryption function. And then the name of this code is, save our changes, and then let's run our code again. Interesting. So now that we've run our code, something immediately pops up. So if you guys remember in one of the previous activities, because we've done a few with this same website, Pico CTF, they often use the same syntax for their, or structure for their flags. So it looks like we found a flag within our code. And if we were to copy this and potentially put it back into that website that we've downloaded our file from, and then submit our flag, we've successfully found our flag. So usually reverse engineering challenges are a lot more complex to the one that we've done right now, but you use similar techniques and concepts when you're doing reverse engineering challenges. So oftentimes you might have to write some code yourself to help decrypt or find the flag, but oftentimes they will also give you some methods to use in the code. That concept is pretty common. So even if you don't know the language of the specific piece of code that they give you, you should be able to pick it up and use the methods or functions that they've given you to your advantage. Usually reverse engineering challenges are in Python or Java because there are scripting languages that usually get things done fast, efficiently, and cleanly, and they're also a lot easier to read for those who are not quite familiar with these problems. So that's reverse engineering, or at least a very simple reverse engineering activity. If you guys want to try some more complicated ones, there are a lot more on that website, and it's very interesting if you like to learn how things work.
Excellent. Thank you, Syra. And that was your intro to cybersecurity. It feels surreal, I know. And there's a lot of information today, as we covered reverse engineering, cryptography, web exploits, and of course, forensics as well. And those are kind of how, those are some of the key parts of cybersecurity and have a lot of challenges on things like PyCo-CTF. So now you're well equipped to start your journey into cybersecurity. And my question for all of you is, what was your favorite thing you've learned today? What kind of challenge do you think you'll do first if you choose to go to PyCo-CTF and try some of the challenges? So yeah, if everybody could like put in the chat which one was their favorite challenge, what was your favorite thing you learned today, anything like that. Oh, thank you. Awesome. Thank you, Angela. And yeah, I agree with Keo. Yeah, it is really fun to read and understand code that you didn't read yourself, just kind of combing through it. It is a lot of fun. Thank you, Amina. Yes, sir.
Sorry. We do have a recording of this workshop, and it will be posted, I'm pretty sure, on the PTC YouTube channel.
We'll also mention something else that just in a second that might interest you as well. Yeah.
That's awesome. We're glad to see that you all learned so much. Of course, there wouldn't be a PTC event if we didn't ask for feedback. We always want to make better events for you, so let us know your thoughts through the feedback form that we will send in our email. As a bonus, if you're serious about taking the next step, we'll send some additional resources like a step-by-step guide for today's activity to whoever fills out the feedback form.
Now, go ahead.
Okay. If today was a bit fast, or you want to send it to a friend who couldn't make it today, check out the projecttechconferences.com/blog for the blog post and recording of this workshop after. As always, stay tuned to at Project Tech Conferences on social media. That's Instagram, Facebook, LinkedIn, Spotify, and TikTok. We're always having more cool events that we'd love to see you at. From conferences to hackathons to more workshops, just like this one.
Thank you all again for coming and learning about cybersecurity. We loved making this for you, so we hope you enjoyed. Have a great evening, everyone.